across the streams, an introduction to Python virtual environments. I'm Hannah. Just a little bit of background about me. So I work at a company called Stratasys, specifically in an office dealing with our GrabCAD tool, which processes CAD data so that it can be printed out on the company's 3D printers. So a lot of industrial designers use our stuff. And it's really fun to see my work incorporated in 3D prints all over the world. If you're interested in working for Stratasys, we do have some vacancies. My personal website, where I noodle around with different projects and have a blog, is raspberrycheesecake.github.io. So who is this talk aimed at? Now, I'm not going to be embarrassed if some people decide to leave, but this is an introductory talk. It's for beginners with virtual environments. Maybe people who've tried it out a couple of times, or even people who've never used virtual environments at all. This talk is for you. It's all about getting started and understanding the mechanisms of how things work under the hood and why you might be interested to start using virtual environments. So package management is really important. Picture this. As a scenario is that you've invented an application that maybe it's making a bunch of money because you're selling it to people. You want to make sure that they get a consistent version of what you're testing out and trying out and developing locally yourself. Or think on a smaller scale. You're developing something and you want to share it with your colleagues, and you want to make sure that you have the exact same code running on your device that they're running on theirs. We've all come across the situation where perhaps a module updates and the APIs change, or a function that we previously relied on has altered. So requirements and package management is all about managing those situations and making sure that we're always controlling what version of different packages we're using. So we can guarantee that no matter what platform we're working on, whether we are on our laptop or a colleague's laptop, that we're running the same code in a consistent way. So these are some examples of package management systems in other languages than Python. So Rust's cargo build is known as being a really good, solid package management system. That's because the Rust developers kind of built it in from the get-go. It was one of their really important values of the language. There's also notoriously NPM and Yarn, NuGet, and I got a picture of Ruby gems there as well. They're all trying to fundamentally do the same thing, which is this issue of being able to have a consistent installation of your application on different laptops, different platforms. In Python, we kind of have a problem with package management. I think this image kind of sums it up. You can often end up in a situation where you think you've installed things correctly, and you're pointing to the right version of a particular module, and then you try and give your project to someone else, and it completely doesn't work for them. It breaks totally in some way that you didn't experience. You never expected it to work that way. The Zen of Python tells us that there should be one, and preferably only one, obvious way to do it. It doesn't really work that way in the world of package management. This is an excellent cartoon from XKCD, which kind of sums up the problem that you can easily get into. The caption, for those who might not be able to read at the back, is, "My Python environment has become so degraded that my laptop has been declared a Superfund site." Yes, the one person who gets the US-based joke. But yeah, it's a big deal, and it really hurts us when we're trying to share our code with other people. So what can we do? I'd like to focus this talk talking about just two tools, pip and virtualenv. To return to the previous slide, just a quick list of the tools that I could have decided to talk about. So we have easy install, pip, pipc, piptools, pipenv, pipx, venv, virtualenv, pyenv, pyvenv, virtualenv wrapper, pyenv virtualenv wrapper, virtualenv wrapper win, anyenv, pywin, And that doesn't even get into the package management tools that have a wider scope or are trying to do more things like conda, poetry, hatch, yoke, hashdist, spac, and so on. Arguably, even things like Docker sit in this zone. So you'll be relieved to hear I'm not going to be talking about all of that giant list of things. I'm just going to talk about two things, virtualenv and pip. So they have a really nice synergy together. You can, of course, use them on their own, but I find that the virtualenv combined with pip gives you a really powerful way of packing up applications and sharing them with others in kind of the simplest way possible. It's not quite as simple as just, obviously the simplest way of sharing your code with others and knowing that it'll still work is just using the standard library, saying, use this version of Python, and with the standard library, use this one script, and it'll run for you. Usually that'll work. This is kind of the next level up of being able to use modules and also being able to tell people how to use them in a consistent way. So first, let's start out with pip. What is pip? So pip stands for a lovely recursive word, which is pip installs packages. Kind of does what it says on the tin. It is actually shipped as part of the standard Python 2.7.9 upwards and 3.4 upwards, which is great. Or you can use the simple script get-pip.py, which is available on the pip website. What pip does is it installs packages for you from a place that is often nicknamed the cheese shop, PyPI, the Python Package Index. So this is a place online where many modules and packages are stored in a standardized way. So the workflow is you call pip install and then the name of your package, pytest, say. It sends a request to PyPI where it looks through the packages, finds one with a matching name and the version that you've specified. And there's both source code and wheels, which is precompiled versions of the module. And it prefers wheels if it can get them, but if not, it'll just grab the source and compile it itself, obtain it, and then place it in your site packages directory. So for those who don't know where your Python lives, so this is in Windows land, usually if you have a system installation of Python, it'll be something like C Python 3.7 if you're using Python 3, or maybe 2.7 if you're using 2, python.exe. That's where the Python executable actually sits. And so a folder within that, where we install what's called site packages, so third-party modules and libraries, is under lib site packages within that directory. So there's a distinction between system packages, which is the stuff that comes pre-bundled with our Python, and site packages, which is optional modules that we can install using tools like pip. We can also pip install from other places. If we want to, we could set up our own package repository online, so long as we follow the format that pip expects to find. We can even pip install from some tar.gz files that we've downloaded already. So you can use pip even if you don't have an internet connection, which can be really handy in certain circumstances. What pip gives us, the link's gone off the screen. What pip gives us is portability. So you'll often notice that there's a file called requirementstxt in many projects that you'll come across on GitHub. What this file is actually the output of an automated process through pip. So the convention is that we do a command called pip freeze, and that gives us the requirements, the third-party libraries, the modules that our code depends on. And we put the output of that pip freeze command into a file that we, by convention, call requirementstxt. We could call it anything. So this is an example of a requirementstxt file. It has specific library names, and it has the exact version that we are using. And then to do the reverse, we just call pip install -r of our requirementstxt file. And it'll go through and recursively install not just those packages, but also anything that those packages then tell pip that they depend on. So this is actually quite short compared to the number of packages that could potentially be installed. Some of these might be relying on other packages, but we don't need to think about how pip does that in too much detail under the hood. All we need to know is that you can pip freeze your requirements and then pip install from the requirements, and you get back what you put in. Obviously, there's a bit of an issue, potentially, with conflicts. If you have a really large number of third-party modules, you could end up in a situation where one thing relies on a particular version of an extra module, and another relies on a different version. So what do? How do you decide which version to use? So pip tries hard to deal with this in a straightforward way rather than a kind of completely accurate way. So it's really fast, but it's not necessarily always going to work out the best solution. So what it does is it uses first found resolution for dependencies, although I know that the pip development team are working on improving this for the future. If you have issues, you can always go back to manually edit the pip file, and you can change the requirements so you can have it permits fields now as less than or equal to, say, 1.0 version, or greater than or equal to 2.3 version. So you don't have to say exactly equal to a particular version, and pip is clever enough to be able to work out what version to pick up that matches the different requirements that you have. If you have a lot of problems with conflicting requirements, I would suggest moving on to a more complete solution, such as Conda, perhaps, which is better at dealing with large numbers of conflicting requirements. But we can get into that in questions at the end if there's time. One thing that I would advise not doing is sudo pip install. So sudo is familiar to those of us who work in Linux land. It means to run as a super user a command that you would ordinarily run as a normal user, but you don't have permissions to do so, so you want to elevate yourself. This can lead to some bad consequences. So here's an example. I'm trying to pip install requests, the request module. It's downloading, it's collecting it, everything looks good, and then it has an error. It couldn't create library Python 2.7 site packages requests. Permission was denied. OK, when I normally come across a permission denied error, I kind of just automatically do sudo the command that I just typed, which is not always a good idea. It's not a good idea in this case either. Instead, what we should do is type python pip install -- user and then the name of the package. That'll put it in a safe place that users can install third-party packages to and access, and it doesn't modify the underlying site packages directory. So what this is complaining about is saying that I'm modifying the site packages that are installed for my system Python, which in Ubuntu is 2.7. That means that my system Python could misbehave itself. Maybe it's relying on some particular package being a certain version. It's really not a good idea to change that or disrupt it. So even though you might be tempted to just go ahead and sudo install it, please don't. Just do install -- user instead. There's another reason not to do sudo pip install, and that is the phenomenon of Python squatting. This is less of a problem than it was a couple of years ago when it was first identified by some security researchers who've written a fascinating series of articles on it on pythosquatting.overtag.dk. So Python squatting, for those who don't know, is a phenomenon whereby malicious actors would upload modules to PyPI which had very similar names to existing popular modules. So instead of requests, perhaps requests or raquests, just as if someone might have accidentally mistyped that in the command line when they're doing their pip install of the different modules that they want. And so subsequently, if you decided to sudo pip install that, so install it to your site packages, then your system Python would be modified so that you're now using a third-party module that could contain malicious code. It could be doing all kinds of things when you import it. Not a good idea. Don't do it. I should mention that PyPI have cracked down on this now, and there's a lot more checks than there used to be, but it's still a definite possibility. OK, so I think we're ready to move on to talking about virtualenv now. So virtualenv has a great kind of combination power with pip. So we talked about not wanting to install these third-party modules in the main system Python site packages directory. Well, virtualenv is a great way around this, because what it actually does is takes your system Python, kind of puts it in a bottle, and copies it, puts it into whatever directory you like. And that's your virtual environment. And you can install whatever you like into that virtual environment, and it doesn't change the contents of the site packages of your system Python, which is really handy for experiments, trying out new things, working on particular projects. So as I showed you the diagram before, what we do when we pip install a package is we send a request to PyPI, we get the package back, and we put it into lib site packages. But what happens when we're using Python in a virtual environment? Once we've activated our virtual environment, we will end up with a directory that we can call whatever we like, with the env name that we've chosen. And there's a python.exe that sits in there. And that's the Python.exe that we use whenever we activate the virtual environment and work inside of it. And when we have that activated, when we call pip install of a package, then what happens is that we go and get that package from PyPI, but instead of putting it in the main site packages, because of where our Python.exe sits, it looks first for a lib site packages folder that's nearer to it. So instead of going all the way up and out to our main site packages folder, it goes, oh, look, there's one right beside me under env name lib site packages. I'll install it here instead. Some editors will allow you to do this in an automated way, which can be really nice if you want to just play around with virtual environments. You don't fancy using the command line so much. I'm going to talk through the command line commands in detail, but just know that these options are available to you even if you're not comfortable with using the command line. So PyCharm, for instance, allows you to make a new environment using a virtualenv, just with a drop-down set of list options. So that's really handy, and you can change the base interpreter as well. So you can see there's a scroll-down option here, and we could choose between Python 2 and Python 3 if we wanted to, if we have them both installed on our laptop. OK, but suppose that we are actually going to do it ourselves on the command line. What do we do? Well, there's just a couple of simple options that we need to use with the command virtualenv. So I should mention before we even get into that virtualenv is installed also with pip. It's just another package. So if you don't have it, then you can just do pip install virtualenv, and then you'll get that. So what we call is virtualenv, and then we can add a -- Python. We can say which version of Python we'd like to use, assuming that we have that on our system, that it'll try and use that. And then we add a name for our env. By convention, confusingly, the default is venv, but you can use whatever you like. I tend to name them after the projects that they're sitting inside of. So it defaults to putting it inside of whatever directory you're working in. So just typing dawnvenv here means that it's going to appear inside of the dawn clock folder, which is where I keep the project files for my project dawn clock. You can put your virtualenvs wherever you like. Some people like to use management tools like virtualenv wrapper, which put them all in one common place and will also allow you to list the virtualenvs that you have so that you can kind of switch back and forth between them and work on them more easily. It's really a matter of taste. I would suggest when you're just getting started with virtualenvs that you just stick with putting them within the project directory that you're working on for that particular project that the virtualenv relates to. that just helps you keep track of it, and it also allows you to have a look inside the site packages folder and just see what's installed there, see how the virtualenv is behaving as you progress. OK, so if we type that command, then we'll see that we're using that Python exe. We see the base prefix change, and we'll see a folder appear inside of virtualenv, which contains the Python exe. And then if we call, and again, this is in a Windows context, if we call the activate PowerShell script, /venv script activate, so substitute whatever name of the environment you've chosen here, there's a scripts folder which contains scripts for activating the environment under various different conditions. There's a shell script, there's a fish script, there's PowerShell, and there's, I think, a couple of other options as well. So it's pretty cross-platform. You should be able to do it in different contexts. I think the only difference with Mac is that you have to do source, and instead of scripts, it's bin, source bin activate, and that'll get you there. And then, as a confirmation, once you've activated the virtual environment, you'll see in brackets beside your prompt a new thing. You'll see the name of your environment appear. So you know that you're working within your virtual environment whenever you see that next to your prompt. And just to confirm that, you can type Python in the command line when you have it activated, and you can check that it's the version that you expect, and you can also check that it's pointed to the place that you chose. So normally when we call import sys and then we type sys.prefix, we'll see a string that contains the direction to our main system Python folder. But actually now when we type sys.prefix, we see that it points at the place that we expect. It points at virtualenv instead, which is exactly what we wanted. So at the risk of everything going terribly wrong, I'm going to try and do a little bit of a demo to show you exactly what I mean. So bear with me because I'm on Mac. But you can see the folder structure here, I hope. So what I did is, so here I am working in the env. I'm just going to make a new shell. OK, so this is on Mac. So it might not be as useful for people on Windows. But I've got virtualenv here underneath virtualenv, which is my main project. So if I just do source virtualenv bin activate, and we see the prompt changes. And so you can always check by this change in your prompt that you're working within your environment or not. And just to double confirm, if I type Python, I'm now in Python 3.7.4, which for me is already confirmation because in the system that I'm working on, I have Python normally defaults to be Python 2.7. So if I'm in Python 3.7, when I type just Python instead of Python 3, then I know that I'm on the right track. But just to double check, I can import sys, and then type sys.prefix. Then I see that indeed my Python executable is sitting in here rather than in my main folder. I'm not sure how, sorry. Sorry, that was a request to increase the font size. I've tried putting this in presentation mode before, and then it gets rid of everything that I actually wanted to show people, which is the directory structure. I'm happy to show people afterwards if you want as well. OK, so just to prove that it actually works. OK, awesome. So some conclusions. If you Google around for virtual environments in Python, you will see a lot of different conflicting advice. I hope that this shows a way forward that can be simple and straightforward, just as a method of getting up to speed and starting to understand what these different commands are actually doing for you. Once you're happy with virtual environments and you're contented putting one together for whatever project you're working on, I would encourage you to look at wrapper tools such as virtualenv wrapper, which is really handy on Linux. And there's now a Windows equivalent, which is virtualenv wrapper-win. That's really for helping keep track of a large number of virtual environments or different projects with some handy commands like work on, which allow you to move back and forth between them with ease. But for getting started, I think that pip and virtualenv, the combination of those two tools, is really straightforward if you just want to get something going and get something that'll be portable enough to share with other people. So I think I have some time for questions. Excellent. So yeah.
Thanks, Hannah. Raise your hand so I can run to you.
If anyone wants to ask about the long list of tools I didn't talk about, I have some detailed notes here that I'd be happy to share with you.
Thank you. Yes, in particular, I had pretty much the same problem of investigating what kind of virtual environments to use. You get a great idea in using this tool manually, but after a while you have to rely on more advanced tools, in particular to prevent pip resolving strategy. So Poetry is definitely great. I definitely endorse it. So did you try it?
Yes, thank you for the recommendation. So for those who might not have been able to hear, that was a recommendation for Poetry, which, as you mentioned, has a bit of a better resolution system than pip.
It's just fantastic.
What's that?
It's just fantastic. Yeah.
It's fantastic. It's more of a complete solution, and I wanted to kind of, the reason I picked these tools rather than something new like Poetry or maybe pipenv is I wanted to pick the ones which have the most documentation and support. I think as Poetry gets going, it might become more of a received solution, and hopefully if people contribute to more docs for it, then it'll be easier for people to get up to speed with.
Just a reminder to keep questions ending with the interrogation mark.
Thank you very much for that. I do genuinely have a question. It's you said you can put it in any directory you like.
What's that?
You said you can put your virtual environment in any directory you
Yes.
like. Can you then take a copy of that directory, put it on some other machine somewhere, and transport it about so you've got everything in a nutshell?
So the question was, can you copy the directory that contains the virtual environment? Yes, with a few limitations. So you can absolutely do that, and it will sometimes work. There's kind of a caveat, which is that if you're doing things that are not pure Python, like you're doing scientific computing type stuff, maybe you have some libraries that rely on makefiles and stuff that's not Python, that's not going to work out for you because those things will be installed globally still, and you'll just have pointers to them from your virtual environment. So in that case, if you're looking for portability for stuff like data science, really large libraries of things, then I would suggest something like Conda as a solution for you for portability. But you will find that, I mean, it's kind of bad practice to check in virtual environment folders to your repo because it's a lot of files and you don't need to, you can just recreate it. But some people do for absolute consistency, and that's fine, you can run it that way. You can just copy everything across.
Thank you, Hannah. We have unfortunately run out of time for questions, so give her a big hand again.